So on the top of page 8, we are given a graph, and more specifically it says the accompanying figure shows the velocity versus time. So it is extremely important that you know what graph you're looking at, because it's going to tell you many different things. And we have the velocity curve over the time interval from 1 to 5. And what we want to look at here is, if this is the velocity, we want to know what we can say about the sign of acceleration over time. So how do I figure that out? What am I looking at? Oh, I look at the slope. Okay, you are looking at the slope. Of the velocity function, v of t. Okay, so then what can you tell me about the sign of acceleration? Yep, the sign of a of t is negative. Oops, there's an I in there. From 1 to 5, right? Okay, because I said that we're looking at the slope. Okay, questions on that first part? That's all we did. Look at the slope. So now we want to know, when is the particle speeding up and when the particle is slowing down. So can someone remind me, you guys actually had this on a test, what do you look at to determine if a particle is speeding up or slowing down? Yes, sir?
Acceleration, velocity.
Okay. You are comparing the signs of acceleration and velocity. So how do I determine the signs of velocity here? What do I look at? This is the velocity graph. Oh, above or below? So my time interval first here is from 1 to 2. And tell me about the sign of velocity. Is it positive or negative? Yeah, positive, greater than 0. Okay. And then my next time interval is from 2 to 5. Whoopsie. So from 2 to 5, yes, velocity, oh my goodness, is negative, less than 0. Okay. So then you guys told me the sign for acceleration, you already told me in the previous question, from time 1 to 5 is what? Negative, based on the slope. So we're going to say that acceleration is less than 0. So tell me from 1 to 2, speeding up or slowing down? Slowing down. So the particle is slowing down. This is our justification right here. You don't have to say anything else. You have your justification. Here, a of t is less than 0, so from 2 to 5, what's happening? Yeah, the particle is speeding up. Okay, does this make sense? Okay. All right, so what can we say about the location of the location? What does that mean? Position, okay? So here we're talking about the position. What can you say about the position of the particle at time 5 relative to its location at time 1, and explain your reasoning? Okay, so if we want the position, we're given the velocity. What are we looking at to identify position? Okay, the integral. So I don't have the function, so I can't integrate. So what's another thing I would look at? The area under the curve. Okay, so if this is the area under the curve from 2 to 5, describe this area for me. It's negative, like a lot negative though, right? Because there's a lot of area there, so this is negative. And then here, my area from 1 to 2 is what? Positive. Okay, so this is positive. Now, if I had to find the area under the curve from 1 to 5, describe for me what that answer would look like. Negative. Why? Yeah, there's more negative area than positive. So if we're talking about the location of the particle at time 5 relative to time 1, what can you tell me about the position of the particle?
It's gone negative displacement.
Okay, negative displacement. So in layman's terms, like someone who is not physics savvy,
Go backwards.
To the left.
The particle's, oh boy, further to the left than what it started. I mean, that's basically what you're saying, but just for any regular person who is reading this, they're going to be like, I'm not really sure what that means. So what you would say is the particle is further to the left at time 5, or you could say t equals 5, then at time 1, because there is more negative area than positive. That's your justification. Okay, and it's relative because you don't have any values. You don't know, but you're just looking at a figure. Does that make sense, though? If you had to add the two together? Questions? One more question and we're done. In example 6. In example 6, we have our velocity function given here, and we have our time interval. So what we're going to do, and I'll just show you what it looks like, we're going to generate a velocity versus time curve, and then we're going to use it to make a conjecture about the sign of the displacement over the given time interval, which in this case is 0 to 1. So the graph looks something like this. This is my y-axis, this is my x-axis. This is just a sketch. I'm just going to go down like this, and then it comes back up like this. And there is, if we're going to time 1, if you can see, there's this area here, okay? And I colored outside the line, sorry. And then this area right here. Okay. So what can you tell me about the sign of the displacement?
Negative.
Okay. So we would say the displacement would be negative because the majority of the graph, or how about the majority of the area, whoops, is located below the x-axis. Again, this is a conjecture, but we backed it up. Okay? So this is, my orange area is negative, my green is positive. So when you add more negative than positive, you're going to have negative. Okay, questions about the first part? Just a drawing. So now in B and C, we're given our function up here. This is our velocity function. If we want to find the displacement, what do? How do you find displacement given velocity? Integrate over the time interval. So we've got the integral, and because our velocity function is already defined, you only need to use v of t dt. You do not need to rewrite the entire thing, which I know isn't that long, but sometimes they're long, and we're going from 0 to 1. Everybody okay? So what is the only difference between displacement and distance if I had to write out how to find it?
Displacement can be negative.
Displacement can be negative, so how do I fix that for absolute value? So you have the integral from 0 to 1 of the absolute value of v of t dt. Okay, so now this is all set up for me. So now what I want to do is go into my calculator. Okay? And we're going to put this function into either y sub 1 or whatever y sub you want to use. So you don't have to keep retyping it. So because I have to do this one more time, I'm putting it in y sub 3. The function is on your paper. So that's what you type. Then I'm going to go into my home screen. Okay, so I just remembered that I put mine in y sub 3. So I'm going to go into alpha window. Option 4, which is my definite integral. We're going from 0 to 1. Alpha trace gives me all my y's. So I'm going to grab y sub 3 with respect to x. This is going to give me my answer. Now remember, this is displacement, right? This is the first one. Okay, does this match the answer of our conjecture in the first part?
Yes.
They asked us to make a conjecture about the displacement. We said the displacement would be negative based on the fact that the majority of the area is under the curve. There's your answer. So this right here is negative 0.1643. Now I need to find the distance traveled. So I need to do the same thing. I'm going to go into alpha window, option 4, 0 to 1. Except now before I do anything else, I need to get absolute value. Absolute value is located in a couple different places, but I always just go back to alpha window. It's the very first one. Press enter, alpha trace, 3, whoop, X. This takes just a little bit longer. All right, 0.1736.